is, therefore they change from 3 diopter to 5.75 from this area we call the moderate. Then less than, higher than 600 minus 600, then we call the higher. Severe is 1,500. So this is the degree. Please remember that. And pay attention to another point. When we divide by the amount of the myopia, which is number, is different from the hyperopia. How different? Let's see. So what's the reason? Reason is myopia, they have multiple reasons, very complicated. For example, congenital. That means they coming past from parents to the kids, or when they birth, all right, to the infinity, to these cute guys, the big eyes, right? If you see the kids, if too cute, that means they have some trouble because these eyes, normally we call it both eyes, too big. They have kind of the syndrome called sticular syndrome. Sticular syndrome. They have very severe congenital myopia and glaucoma. Because why their eyeball is so big? The main problem, myopia is second. The main problem actually in this kind of patients is glaucoma. Because their intraocular pressure is so high, they keep push the eyeball, making it grow up. So actually, this is eyeball have the higher intraocular pressure. Therefore, you look like big, right? Therefore, after the 6 months or 1 year, if you don't treat that, these kids will lose their vision and never correct it. So it's very dangerous. If two kids, if you find the kid is like a big eyes, think a second, all right? Don't say, oh, you're so cute, so good. If too cute, think about this problem. Second is acquired myopia, right? Now most of the people, almost all of our students, is acquired. That means after the 2 or 3 years old, maybe the kids normal, they watch a lot of cosmic movie, all right, read too close, and their home is too dark, they make this. And another is young kids, 12 until maybe the 21 years old, is myopia called juveniles, onset myopia in the early childhood or teenager. They can continue to grow until 21. For the adults is divided by the 40 is a bridge. Before the 20 to 40, we call that onset, early adult, and after 40, we call the later adult onset. Normally, this kind of patients, first reason you think about the cataract because the early stage. All right, so this is early adult onset. A little bit difficult. No one knows what's that happen. Maybe work too hard, or maybe they read too much book. But they not too much people like this. Not a lot of people. All right, most of the myopia coming from this age. Myopia after infinity on in adult. That is, when you have the myopia in the young kids, you will wear glasses and never take it off. So we already talking about the prevalence of the myopias. All right, prevalence of myopias in the school age. This is a very old data. It's a little bit old, 10 years old data. Now I can tell you the situation is coming worse. It's coming worse. Here is they coming from 1983 to here 2000. I can tell you 2010 they keep like this. They keep going up. I think is everybody will be go to the myopia. So if you don't wear glasses, looks like you are abnormal, right? So this brings another ethics questions. How do you define abnormal and normal? If 90% of people is myopia and 10% of people do not wear glasses, so can you say this 10% of people is normal and 90% of people is abnormal? So that will be interesting questions. Okay, so this is Hong Kong. Hong Kong, in my first class, we are talking about number one, all right? More than 85, 90. If we are the number one, no one can say, number two, no one can say they are number one. Actually, we are the top in the world. Okay, then I will switch back to the normal slide. I'm going to show you something, some lens, because next slide, I'm going to talking about the corrections. So, so far, how about my voice? How about my voice? Give me some feedback. Okay, thank you. All right, thank you very much. Thank you very much. I think the online, this is only advantage. The voice is clear. You can see the video over and over again. Okay, when we're talking about the corrections, right? So normally we are talking about we using the prism. So what is a prism? Here I bring two lenses. One is called the concave lens. Another one is convex lens. I think our student can see very clearly. This lens, normally we're using for corrected myopias. So you can see in the middle, which is very shallow. In the peripheral is thick. We call it concave. We're using this lens to correct it myopia. Why? I'm going to show you in the next slide. All right. But put in this lens in front of my face, you can see I became a very small person, right? Tiny person. However, this lens you can see in the middle is thick, in the peripheral is shallow. We call it convex lens, right? Actually, it's enlargement everything because it's so big. So my face cannot put in this lens, right? You can see only part of my face can show up. So this is 20 diopter. So when we're talking about the correction for the lens, for the myopia and the hyperopia, we are using these two kind of the lens. So how they work? How they work? I'm going to show you how they work. Okay. So one is the convex lens. We call the positive lens. Why we call it positive lens? You can see in the middle part, which is thick, in the peripheral, which is very thinner, right? We call it positive. That is plus. When we talk about plus, you can see it's then like this. Contract to that, we call the concave lens. Concave lens, just like I show you, we have thinner in the middle and thick in the peripheral. However, because they are focused, they have the real focus. I remember in the middle class, you can using this light under the sun. Actually, you can ignite a light, a fire, because they can put everything in the one point and increase the temperature. Yes, so they have the real focus, right? Therefore, according to this, we give them positive. For example, then we're making another idea called a diopter. Diopter is one divided focus length in this meter. So for example, like this patient or like this lens, if they can focus 20 centimeter, right? Then 0.2 meter, then this lens, the power is 5 diopter. That means if you can have more power focus close to the lens, this power is bigger. So for example, if that is 10 centimeter, then this power will be 10 diopter, right? That means if they close, have more power, make this focus plane close to the lens, they have more diopter. So this equation give you the idea like this. So why are we talking about concave, which is minus? Because when the light coming through this lens, they don't have the real focus. You can see this focus point actually is not real. So therefore, we're using the minus. Actually, it's not the real focus point. So, but the idea is same. They have minus 20, 1 divided minus 0.4, 2 is minus 5. So this is the two lens we are going to using to correct it, myopia and hyperopia. I have a video. Actually, I have a special effect to show you. I'm going to switch to the whole screen mode. Okay, so this is we are talking about two lens, convex and concave. And actually, there was a prism. We all know of the prism. Prism in our middle school class, we know that light coming from here, they have the prism actually triangle at the top and the base. The top is axis and the base. So when light coming from the horizontal way through this lens, they will refract it, not going straight. Actually, they have some way to change their way, right? Therefore, the concave, when the light coming through here, you can think of a two-point, the prism to here. So one prism, when we come in here, they will going away from the central, another one the same. So therefore, there was focus plane is minus. So normally we use negative lens to correction the myopia. So this is the idea. When we using the concave, like the point to point prism together, then they can making the minus power. So how about convex? Convex looks like two prism, but it's not a point to point, but a base to base. Because after base to base, the direction is changed. They can focus on the one focus point, which is real. Normally we use positive lens to correct the hyperopia. So I'm going to show you again, because this is some basic idea. Normally the light through the prism, they can change the band of the light outside the way. So in the concave, we are going to correction the myopia. We're using the two concave, looks like two point to point prism together. Then they can making the minus focus. As to the hyperopia, we use the two prism, which is base to base. So they can focus on one point, which is real. So how do we correct it on myopia? So here we are going to using this to show you. In the myopia, in